This is a lesson on sample space, probably the most important part of probability and what we'll spend a lot of time in other videos talking about, how to calculate. So this is really basic and kind of entry-level stuff for probability. So first of all, sample space, often defined by or symbolized with the Greek letter omega. So we have to first identify what experiment we're looking at. So examples of experiments would be a coin flip, rolling a die, or choosing a card from a standard deck. Other experiments could be pulling a sock out of a drawer and trying to match them, sort of thing. But I'm going to just go through these three examples. For this first example, the coin flip, the sample space are all of the possibilities that we could get in that experiment. So to me, there's heads and there's tails. That is the entire sample space. It's a small grouping because it's a simple experiment, and the number of elements in that sample space is 2. And looking at the next experiment, rolling a single 6-sided die, we're looking at, you could roll a 1, you could roll a 2, you could roll a 3, a 4, a 5, or a 6. And each of those represents one of the sides of a cube. All right? And so those are all of the different outcomes, and that is the sample space. Another thing that we could think about here is that, I'm just going to move these down a little bit because I'm going to talk a little bit more about each of those situations. It doesn't really make sense in some cases to write out all of the words and all of the options. So in some cases, you'd shorten these out a little bit, like so. And then instead of drawing the dice, you could just simply use dots, or you could even just say, hey, 1, 2, 3, 4, 5, the symbolic representation of the actual outcomes. And again, looking at the number in this sample space, there are obviously 6. We can literally just count them. And depending on your familiarity with a deck of cards, we could write out that there are 4 suits. I'm going to color code this a little bit. We have diamonds, hearts, we have spades, and we have clubs. And in each of those suits, we have an ace, a king, a queen, a jack, 10, 9, 8, 7, 6, 5, 4, 3, and a 2. All right, so we have that. Four times. Oops. Try that one more time. I'm actually going to call those red and a copy and call those black. So we have, basically we have the diamonds, the hearts, the spades, and the clubs, and that would be the entire sample space. And since we have 13 in each of 4 suits, there are 52 total cards in the sample space. Now, if you think back to the formula for probability of event A is the number of successful outcomes over the number of possible, which I'm now going to just use that omega symbol. All right, so the probability of picking the queen of hearts, well, there's only one queen of hearts, and there are 52 cards, so the probability is 1 out of 52. The probability of picking any card less than a 10, well, there's still 52 in the sample space. How many cards are less than 10? I like to look visually at this sample space, and now I know that there's 4 times 1, 2, 3, 4, 5, 6, 7, 8. 8 cards that are 10 or less in each. So there's 32 out of 52. And we could reduce that down by 4 and get 8 over 13. And personally, I prefer the fractions when I'm writing probability. So that's a quick look at sample space. And it really